Okay, so I'm going to show you how to do the solution to the problem that we had of a football kicked at 15 meters per second, an angle of 30 degrees above the horizontal, and it says to assume the initial height is 0. And it's asking what's the maximum height, how far away does it hit the ground, how long is it in the air. So again, we do gather and organize. So we look at the problem and we pull out all the numbers. So speed 15 meters per second, that's the V0, at 30 degrees above horizontal, that's theta 0, and they tell us y0 is equal to 0. So start off, always the first things we do is draw a picture. So in this case, it's easy. The ball is kicked from the ground, goes up, and lands at the same height. And we know that V0 is 15, and theta 0 is 30. Okay, so we've done the gathering, and now we're going to organize. And to organize, I've got written there in red what we do. So first thing we do to organize is break V0 into components. So remember, V0x is V0 cosine of theta 0. And so I've got V0 is 15, theta 0 is 30. And so if I put my numbers in, I get that V0x is 12.99 meters per second. I'm not going to round that off to 13 yet. Remember, I'm going to keep unrounded numbers. V0y is going to be V0 sine theta 0. You can see this is exactly the same as other problems. You're just going to plug and chug. You should always be able to get this part of the problem done and at least get partial points on the test. So remember, for this module, this is pretty much the only kind of long answer question that you can get is some kind of projectile moving through the air, and the only three things I can ask you is high, how far, how long. So if you know how to do that, you can do anything. So the sine of 30 is a half, and that's a good way to check whether your calculator is in degrees or radians on the test. And if I remember, I usually prompt the class to just type in sine of 30. If you don't get 1/2, if you don't get 0.5, then your calculator might be in radians and your answers will all be wrong. All right, so I've got V0x and V0y. So I've done the first two steps. All right, and then I had that little table that gave you the hints of how to find the maximum height, the range, and the time in the air. So the easiest thing to find is the range, because for this case, the football is landing at the same height at which it took off. So I can use that equation in red. And I don't have to do the parts in order. I could do B first, and then I do C, and then I'll do A. But let me just do them in order. So what's the maximum height? So what was our recipe? For maximum height, at the point when it's at its very highest, then the velocity in the y direction is 0. And so if I look, I've got Vy, I've got Vy0, and I've got G. And the only thing I don't know in that bottom equation there on the right is delta y, and that's what I'm solving for. So remember, it says to assume that y0 is 0. Okay, so this equation then becomes, let me write it over here. So for part A, it becomes Vy squared is equal to Vy0 squared. Okay, and you can see that I interchangeably write Vy0 or V0y. It's the same thing. Minus 2g, g is 9.8, times y, because my y initial is 0. And I'm trying to solve for y. Okay, and I've got the Vy0 is 0. So I can go ahead. I usually like to solve it algebraically before I put the numbers in. But let me go ahead and put the numbers in. Because I know a lot of students do it with the numbers. So I've got 0 is equal to 7.5 squared minus 2 times 9.8 minus 19.6 times y, and y is what I'm trying to find. So what I'm going to do is I'm going to take, remember, if I want to solve for y, I'm going to take that term onto one side by itself. So since it's subtracted on this side, I'm going to add it to the other side. So I've got 19.6y is equal to 7.5 squared. And so y is just going to be 7.5 squared over 19.6. And I get 2.87 meters. And now I need to look at my significant figures. Looks like I've got 2. So now I'm going to round that to 2.9 meters as my final answer for part A. All right, so that's part A done. Part B, how far does it go before it hits the ground? Well, since it lands at the same height as which it took off, I'm going to use the range equation. So the range equation is that one in red, that the range is equal to v0 squared. And for this one, for v0, I use the whole velocity. So I use the 15. G is 9.8. Sine of 2 times the initial angle. So it's going to be v0 is 15. 15 squared over g. G is 9.8. Move this up a bit. My stylus doesn't want to work so close to the bottom of the screen. Over 9.8 times the sine of 2 theta. So how do you put the sine of 2 theta in your calculator? What you do is you do sine of 2 times 30. So that's actually the sine of 60. All right, so you're going to put in 15 squared over 9.8 times the sine of 60. And if I do that, I get 19.88 meters. And let's see, if I want to round that to 2 significant figures, that would be 20 meters. And if I want to show that it's 2 significant figures, so it's 20 meters, I would write that as 2.0 times 10 to the 1 meters. Okay, so first I did my gather and organize, and now I'm doing my algebra and my learning or looking back and making sure I've got the right units and right significant figures. Okay, we're almost done. So how long is it in the air? Well, time that it's in the air, I can either use, if I use the range equation, that it's the range over v0x, or I can use the quadratic formula. Either of them will work. If I have the chance, I will never use the quadratic formula because the more numbers you put, the more algebra you have to do, the more likely you are to mess up with your numbers. So I always use the simplest possible solution, and there's always more than one solution for it. So let's do this so I can solve that the time is equal to the range divided by v0x. And I know both of those numbers. So my range, I'm going to put in my unrounded off number so I don't get a wrong number, 19.88, divided by v0x, which was 12.99. And I get a time of 1.53 seconds. So there's an alternate way to solve for the time, and let me quickly go through this. So let me put it in red so you know it's an alternate way. So what other way could I solve for the time? Well, in this case, I know that at the highest point, Vy is equal to 0. So I could use Vy equals Vy0 minus gt to solve for time. Okay, so I know Vy is 0, Vy initial, I know 7.5, I know g, I can solve for time. But remember, for this projectile, the time at which it's at its highest point is only going to be half the time that it's in the air. So I would get this time. So if I find the time using this equation, I have to double it to get the total time. But we can do that. So if I put in my numbers, I get 0, is equal to Vy0, 7.5, minus 9.8 times t. So t is equal to 7.5 divided by 9.8. So that's 0.75 seconds, a little bit more than 0.75 seconds. And that's half the time. So if I want to find the total time, I have to write the total time is twice this. So the total time, let me write t total. And again, my stylus has stopped working. T total is equal to 2 times 0.75, which is 1.5 seconds. So if you do it this way on the test, make sure you justify. Tell me why you're multiplying by 2 to get your final answer, or I'll take off a bit of points. But usually you'll find as we go through the course, there's so many equations that there's always more than one way to find the answer, and no one way is correct. Usually I try to use for myself, I try to use the simplest possible equation to solve for it, just because then I'm less likely to mess up when I'm doing the algebra or putting the numbers in my calculator. All right, so I've got all the answers. The one thing I didn't do here is for this time that I solved for the first way for part C, I never rounded that to the right number of significant figures. So I would have got half a point taken off my answer. So I need to take that to 2 significant figures. So I'm going to make it 1.5 seconds. Okay, so that's it. That's all the things that you can be asked to solve for. Make sure you're able to do problems like this, and you should be good for anything that you see on the homework or that you see on the test.